Hi everyone, this is Mr. Broyles from Silver High School. Today we are going to be talking about Newton's second law. And it's Newton's second law of motion. All right, so there are some main ideas we need to think about with Newton's second law of motion. The first one is that acceleration is the result of unbalanced forces. And we'll look at a simulation here that will show this to us. And the second main idea is that a large force makes proportionally larger acceleration. And the third main idea is acceleration is inversely proportional to mass. All right, so let's look at our simulation. So I have 200 a 200 kilogram refrigerator. Now I'm going to put my values up here so that I can see what my applied force is, what the sum of the forces is, because this is going to be the sum of the applied force and friction. And then I've got acceleration. So what I want to do is I want to make a data table. And I want my data table to be to have three parts to it. And I want to have net force, which will be the sum of my forces. I want to have mass, and then I want to have acceleration. So if I put 500 kilograms of force, notice that my frictional force is 500 newtons, my applied force is 500 newtons. That makes the sum of my forces 0. And therefore my acceleration is 0. So my net force, the sum of forces, is 0. The mass is 200 kilograms, and my acceleration is 0. Now the net force is in newtons, the mass is going to be in kilograms, and the acceleration is in meters per second squared. So there's our first. So we're going to get rid of this, and we're going to bring up our bucket of water. Now I'm going to go ahead and I'm going to put and this was with 500 newtons of applied force. So I'm going to put 500 newtons on again. And when I look at this, now my sum of forces is 312. My mass is 100 kilograms, and my acceleration is 3.12 meters per second squared. All right, and that was the 100 kilogram object. Now I'm going to bring up my 80 kilogram object, and I'm going to put 500 newtons of force on it again. So I'm going to have 80 kilograms, and my sum of forces is 350 newtons, and my acceleration is 4.38 meters per second squared. So I'm going to bring him down, and I'm going to bring up my 50 kilogram box. And again, I'm going to put on 500 newtons of force. So the sum of my forces is 406 newtons. And come on. And the acceleration is 8.12 meters per second squared. So now I'm going to bring up my 40 kilogram girl. And I'm going to put on 500 newtons of force. So my applied force is 425 newtons, and my acceleration is 10.63 meters per second squared. All right, so we've gotten some data now. And what I want to do with this is I want to find a relationship between net force, mass, and acceleration. So if I want to move from 312 and I divide that by 100, or I want to move to 3.12, I divide that. So I'm going to have my net force divided by my mass is going to be acceleration. And let's see if this works. 350 divided by 80 is going to be roughly 4.38. And if we get our handy dandy calculator here, and I go 350 divided by 80, I get 4.375, which is 4.38. So if I do 406 divided by 50, I get 8.12, which is what I have here. And if I do 425 divided by 40, I get 10.625, which is 10.63. So I've now got my relationship here that says the net force divided by the mass equals the acceleration. This is a very key equation. We can also see this written as F equals ma. You may have heard it that way. And we can say that m equals the net force divided by the acceleration. So I'm going to put up my math triangle. And I'm going to say that A equals my net force divided by my mass. So to get these three equations, A equals F over m, F equals A times m, and m equals the net force divided by A. So basically this is Newton's second law of motion. Have a good day. I'll see you in the next video.